Hey everyone, my name is Wahid Lutfi. I'm going to provide you the NumPy module tutorial number 7 today. And we have already covered tutorial number 6 on NumPy module, which was the operating system module inside NumPy. And tonight we're going to discuss tutorial number 7 for SYS module. So let's get started. Let me share this with you first slide, and then I'm going to go from the first slide. Tutorial number 7, the SYS module, which is inside the NumPy module. And then this is again Python. And then we're discussing NumPy library or NumPy module, which has the OS module, the SYS module, the math module, the request module, the random. There's a lot of modules as well as a lot of methods and arrays and data structure that is written in C, and it is going to help you really fast do computation on numerical, scientific kind of linear algebra, everything else. So here I'm showing you how to import the NumPy and do a dir on numpy.sys. But I'm going to show you a lot more on the examples and then the lab activity. What I have written here that don't import the SYS module once you import NumPy, because NumPy contains the SYS module. Similarly, if you're importing NumPy, don't import the OS module or the random module. It all contains there, or math module. So you can use them like this in p.sys because it is inside the NumPy module already. Okay, so this is my YouTube channel, youtube.com/@MyWebUniversity. @MyWebUniversity is my YouTube handle. So you can subscribe if you haven't already. I really appreciate it. And I'm providing you a lot of technical documentation as well as these videos online that you can learn Linux, Unix, Windows operating system, PowerShell, command line syntax for all the operating systems that I have mentioned here: Mac, Linux, Solaris, Unix, Ubuntu, Linux, and then Windows, and so on, as well as programming language like Python, C, C++, and then awkward programming, shell scripting, and then guidelines to stop hackers, ChatGPT related stuff, a lot of the syntax and semantic of the languages are explained here. So you're welcome to like and subscribe. And let's get started with today's session, which is, if you're looking for documentation, there's 3 places for Python. You can go to python.org under the documentation and then get the latest documentation there. So that is your friend that you can get everything for Python under python.org/docs. It's comprehensive documentation there. If you're looking for NumPy module, visit the numpy.org website, and you will get a lot of documentation, tutorials, how to section, and examples that you can practice it online and then do it. You can see also that other modules like pandas module, then SciPy modules. There's a number of them in addition to NumPy module. So you can go and practice them as well. Also, you can visit my my website, which is a secure page as well, MyWebUniversity.com. And then if you go to the next page here, and basically I have an online book called The Direct Path to Linux Ubuntu, and it's about 8 chapters. All of these ones are online. You can practice them if you're learning Linux. If you're a beginner, go to chapter 2. If you're intermediate, go to chapter 3. And if you're advanced, go to chapter 4. And then for those ones, I have videos online that you can watch. And there's commands that you can practice them. And if you haven't watched them, and just go to one of the YouTube video, and then I have explained them extensively. And then chapter 8 is a PDF version for 6,600 Linux commands. So all of them are here, just basically section 1 through section 9. I have provided all of them. And then all you have to do is, if you're looking for, let's say, Python, you control F and then say, type in Python here. And then you could see Python version 3 here, and then just open up the PDF file and read it there. So there's a documentation and resources available for you for all of them, including the Python website and then the NumPy.org website, and as well as maybe just comment on the videos, watch them online. So you can learn it by just watching it. You don't have to read anything, but if you're interested to read it, you can go to the python.org website or numpy.org or just MyWebUniversity.com. So there you can see it. Similarly, I have man pages for, help for the Windows version. So if you're looking for the Windows command line here, there. And then when I say there's all these commands, so no matter which system you use, there's always like some PDF file that I built it for you that you can just go for. PowerShell. There's about 1,394 commands and PDF files here that are listed. So like get TPM, if you click on it, you get the PDF version of it. It doesn't matter what the command is. It is all available. And I have written that one also on Python, FPDF library generator, and the actual PowerShell command help, get-help. And then here I'm just showing you for each command that you type in dynamically, it gets generated this PDF file. And I gave credit to those companies that work, including my own website, MyWebUniversity.com. Python.org, Microsoft for PowerShell, and PDF, a free PDF for library generator, which allowed me to generate this PDF format in this. The nice thing is all of the commands that's dynamically. So whatever command you click on, if you click on, let's say, the next command here, get net adapter, whatever command is the one that you're looking for, it will just show you the specific command for that. Get network adapter VMQ, right? So that is there. If you're looking for a particular command, like here, just press Control F. Sorry, I just clicked on it rather than doing Control F. Do a Control F and say get dash process. So then, since I click on it, now I have to wait on here and then say Control F and get dash process. And then right here, the get dash process comes in. So you can search for any command and then get exactly that command. You can see get dash process is showing here. And then the full command was get help space get dash process, and this is the output here. So let me just close this one. We don't need it anymore. Close this one. We don't need it anymore, and close this one. We just stay on this one and then go back to this tutorial, which we already discussed that we're going to cover. So I'm going to open up a command shell prompt, clear my screen, do a pwd. I'm in the right directory. So I'm going to say IPython, IPython to get to interactive Python. Now, if I do a dir here, or just do a simply print dir object, so everything is horizontally listed here, you can see that the list is a number of methods and double underscore method that are available. Now I'm going to say import NumPy as NP, and then say print dir of dir again. You could see that it is NumPy gets loaded already here. If I want the entire NumPy, I could say dir of NumPy. You could see that it is huge. And if I want it in not vertical format and horizontal format, then I need to do a print on here, then it lists it. Similarly, if I just want to see on tutorial number 6, we discuss OS, you can see the OS module. But today we're going to discuss the SYS module, and the SYS module is huge. So I'm going to say, let me clear the screen so this information is on top. I'm going to say np.os.system and then clear the screen here. So that's the operating system clear command. I'm going to do this np.sys to list the SYS module. Even the SYS module, it is huge. You can see that it is start here and it is there. But we're going to just discuss a few of the attributes and a few of the methods, and then we're going to just do it on both platform, on Linux platform as well as Windows platform. So let's do one more time clear, and then I'm going to say np.sys. Let's say first I'm going to say what platform I am. That should say Linux. And then similarly, I'm going to open up here a command prompt on Windows. You can see if I type in CMD here, it shows that I'm on a Windows operating system. So clearing my screen here, and then I just say CMD. You can see I'm on a Windows prompt. When I type out exit, I just only need one session of command prompt. So that is good enough. I showed you that one. You can also get system info here, system info, and then find string, and then say OS name. OS name, sorry, find a string system. Let me just clear the screen first. I must have typed something wrong. System info, and then find a string /I, and then OS name. So if I just look for that one, it's going to say OS name is Windows 10 operating system, as you can see here, Microsoft version 10. And then now I'm going to say, let's get Jupyter Lab. Let's start Jupyter Lab so I can have to go to a port of localhost 888 and then start using Jupyter Lab on this Windows operating system and get the same information and the way we did it. Since this one is going to take a couple of seconds or maybe less than a minute, I'm going to just run commands here on the Linux side, np.sys and sys. We know the platform. Let's say we say what is the executable? Executable. So now you can see the executable version is user bin Python 3. So I could also get that same information, say np.os.system, and then say which Python 3. This one will say the same path as the SYS module that reported here. So the next command, this 0 means the status of the system function call was successful. And then here I'm going to just run the np.sys.version. So the version itself, you can see it says that it's 3.8.10, which is the same. So on the OS system, I could have also said, and instead of this, I could have said, give me --version, --version, it will say 3.10 and this. So from the sys, we can get it, from the OS, we could get the information. Now, if I just do this one, info_version_info, you can see the major is 3 version Python 3, the minor is 8, and then the micro is 10. So that's the detail of that information here. And then we can also get other information like sys.path. So let's just clear the screen again here. We just run a sys or sys.path. So that is the path of the binaries where it finds the executable, like where are the packages on the site packages and this information, and then by default, the user local bin is connected there. You can always add information onto the path. So if you're running a program from another location and the argv is not having information there, then you can just do it. And np.sys.argv will actually show you what was passed on. In this case, we did not give any argument to IPython. If there was any argument passed, argv sub 0 would be pointing to this name, argv sub 1 would be pointing the next argument, and argv sub 2 to the third argument, and so on. So let's get back here. Now this is already started on localhost port 888. That means I can go to the browser and then just already have this module loaded. So earlier I was just doing a demo to just see it. This session is already open, and then run this command. At this time I said how to import NumPy. This is again tutorial number 7 on Windows platform. And then we're doing a dir command here. The output would be just, if I run it, the output would show. Yeah, this one. Okay, so this one I have to run first. And then this one next. Yeah, so now you can see the output is showing here for the import NumPy as np, and then I did this one. Similarly, I'm going to minimize this window. And then the platform here, you can see it is Windows 32. On Linux, it was called Linux, and then on Mac, it would give you like Darwin. Darwin is based on BSD version of Unix, which is a Unix operating system. BSD is the Berkeley software distribution at Berkeley, University of Berkeley, and that was written FreeBSD, BSD, on Darwin, and SunOS are all BSD based. So we are going to discuss a few more of those ones. np.sys.executable. Let's look at that one on Windows side. You can see the path of this one is c:\user. So this is Windows, it is this path. And if I just say np.sys.version, you can see the version of this one is going to say 3.8. Let's see, it takes a little bit of time. Yeah, it is slow. So sometimes this thing just slow down and hangs there, and then I had to restart it earlier. So let's see if it comes back. The kernel restart the last time did not help us, but so I could also get the operating system command by saying that, let's see if I could just run one of the OS command and say, and this time I'm gonna run the directory command to see where I am at. Now, if this command doesn't run, that means that it is hanging. Okay, it looks like it's hanging again. So let me just do a kernel restart. Restore the kernel and then see if that will just improve it. I'm gonna close this one, and then let me just close this one also. We don't need these ones to be there, and then let me just do a dir of np.sys to see if I get it or not. Yeah, it looks like that command doesn't run. Dir of sys dot let's say argv. That's shoulder form. And then I'm gonna say restart kernel and clear the outputs. Okay, so this doesn't look like it is responding. What I could do is here, say CMD here, leave that one a little bit time to see if it comes back after the restart. I could do the same thing here with IPython. So I could say IPython here, and then get the interactive Python, and then load it and say import a NumPy as np, and then np.sys.executable, and then run that one, and np.sys.executable. Why is not coming? Has no attribute executable, np.sys.executable. Let's say np.sys.version. Yeah, it does show that one. So the executable might not be an attribute here on this one, but on the Solar Linux machine was. So what we could do is here say dir of np. Let me move this one up so you could see what I'm typing. Dir of np.sys. I'm going to exit out of this one also. The coloring is bothering me. And so I'm going to go to just to Python 3. This one say import NumPy as np. So you can see the list of resources that is available. It is very good. And that way you can see np.sys.version info, np.sys.version, np.sys.platform. You can get all that information here, and then say np.os.system. Let's clear the screen here. The command is cls on Windows, and then say np.sys.argv. Since the argv was empty, I'm going to just run this one with a little bit argument to just see how we can get the argument inserted there. So type of np.sys.argv, you can see this is just a list. That means that I can insert into it. So if I just didn't do anything from the command line to call this program, I could have just done that one. I'm going to insert something here. Say np.sys.argv.insert, and I'm going to just say at the first index, just insert, let's say, computer science. And then there's now if I just print this one, you can see in computer science added. Now if I just want to add math as well, and then math is added. So every time you add another one, it pushes the stack on the first, last in, first out. So the first item that was inserted, it was always inserted on top of the stack. In this case, is this. So I'm going to type in physics, and then add, let's say, biology also, and biology. So this is inserted now. np.sys.argv is there. So if I just say np.sys.argv.pop method, and then just pop. Now the top one was this. Now if I print it, notice this one is only those 4 of them. If I want to pull computer science, then I have to do another pop. And now computer science is popped, and then biology, physics, and math are there. But if I want to just insert computer science again, then I could just insert it on the first element. And now notice that this is growing back again to 4, and computer science being the first indices. So I can also say for item in the list of the sys.argv, so I could say np.sys.argv, and then say print, and use a f string, and then I'm going to say, in this case, I'm going to say np.sys.org.v. Actually, sorry, I need to just type it correctly here. I missed a V here. So I'm going to do the same thing here and then do a print F and then start np.sys.org.v sub and then just give item here as a string that we want to print and then is equal and then we just need to put the value of the next one, which is np.sys.org.v sub item and then close this one, close this, and then close that, and then let's see, the less than dices must be integer or slice, not a string. So somewhere I mistyped that one. So let's see, np, this for F statement. Yeah, this is how you fix it. So the np.sys.org.v doesn't need to be in braces, but item is the variable that changes. So every time we want to say np.sys.org.v of computer science, it is this. And if we just want to print it without the entire thing, we could have just done that one also, like that. That did not work last time and it wouldn't work this time either. So let's just correct it with the one that we did here for the for statement. Sorry about that. Let me just get it. So argv this and then there. So you have the output. Now I'm going to just exit out of this one in order to show you I'm on a Windows operating system. So I'm going to go to this directory called demo and programs, and then type in sys Python, and then here I have a bunch of programs. So one of them is called an NumPy SYS module. So let's say NumPy sys.python. So I could say type NumPy sys.py. You can see this program. I'm loading NumPy as np. Then I check the length of np.sys.org.v. If it's less than 3, then I say I don't have enough argument. Otherwise, I read the argument argv sub 1 and then change it to integer because that's by default as a string. Then I change it to integer. Then I do addition. You can do addition, multiplication, anything you want to do with it once you have the arguments. And in this case, I'm only doing summation of the to integer variable and that I convert to integer. And then I say, this is the data that you provided. So in order to run this one, I could say Python 3 and then NumPy sys.py. If you run this one, it just says not enough argument, right? So clear the screen here. If I look at the type of that command is that, and then when we run it without the argument, it just says not enough argument. But we want to give it enough argument. So how do we give enough argument? 10 and 10. That's 20. So 10 plus 10 is 20. You have provided the following arguments. NumPy was the first in the list, and then 10 and 10 was there. And then here our v sub 0 was pointing to the program itself and so on. So let's just clear the screen and then run the same one. This time I'm going to say 5 and 10, for example. You can see that one. So if you change the values of this one 50 and 5, we want to add those numbers. You can see the addition is always done, carried correctly. And then the argument sub-0 is always pointing to the main program, NumPy SYS. And then argv sub-1 is pointing to the first argument. Argv sub-2 is pointing to the second argument. So this is how you do this. Now, if I just say Python 3, from the command line, we did this one. Let's say go to Python 3 here, and I'm going to just say import NumPy SYS. So notice that it runs with not enough argument here. If you just are running it from command line, it is there submitted. But then if I say it exit out already because I got out at the end of this one. So Python 3, and then I say import NumPy SYS, and then 50 and 5. And then notice this way you cannot run it this way. The only way you could do is say, okay, np, let's say dir of the object that are available, and p is not there. So I could say import the NumPy as np, and then dir of np. Now np is available. I could say np.system.os and .system, clear the screen, and then since this is a Windows command operating system, and then I'm going to do a CLS. Then at this time I could say import NumPy .sys like that. They exit me out as soon as I run it from the command line. So that is not a good example to show you here. And let me show you one more thing here to see if this one came back or not. No, it did not come back. So the interactive Python module is not going to show, which I have to do another restart the kernel and run all cells and do that. And then at the same time, I'm going to demonstrate the rest of this video on Windows, because we don't need to, I mean, on the command line we don't need to demonstrate too much on the Jupyter Lab. Let's look at this one through np.sys.path. We already looked at it, and I'm going to get some more information. So yeah, the np.sys.argv, if I exit out of this one and then clear my screen, the program that we had on the screen here, I'm going to say cat -n numpy sys.py. This see what director I am. Okay, numpy. Okay, that file is not there. So let's see what I have here. I'm going to say mysys.py. I believe that file is there. So let's see if mysys.py. This file was just loaded on the previous videos that I did. Import sys. So I created importing sys, and I'm not using NumPy here. That's a very good example I could show you for both of them. So in order to look at this file, I'm going to say, let's run it first with Python 3, and then say mysys.argv, mysys.py, and then I'm going to just not give it any output. It says not enough output, so that is good. So it is there, but this time I'm going to give output of 7 and 10. Should be 17, and it shows that it is exactly that is there. So if I give it a big number, it is just adding the 7 with the 1000, and it shows the argument 2 was 1000. So at this time, I'm going to do a copy of my sys.py as my, instead of the MySys, I'm going to say NumPy SYS.py. So now I have, if I do star sys.py, you can see that I have the two files. So you can see the two files. This file is also a copy of that one. They're both 422 bytes. So if I say cat -n numpy sys.py, you can see it is those 18 lines, but it is not using NumPy module. This time I'm going to do a vim on NumPy sys.py, and I convert everything that here to the sys. So let me change the coloring scheme to color blue. I think that looks okay. That's not that bad, but let's see if I could just do one more thing. Color wrong. No, color. Let's say tab blue, dark blue, default. That's not good. Color. So you could do color on them and change the color, and then change it to a different coloring scheme to make it look a little bit different. I think this one more readable, this one, than all of the other ones. So I'm going to use this one. And then import sys, and then, so instead of importing sys, I'm going to say import NumPy as NP. So we're going to say to demo the NumPy SYS module, argv sub 0. So right here, I'm going to just say np.sys.argv. So when we do the NumPy here, everywhere that it's I'm using the sys, I need to change those ones to np.sys, because I have to use np.sys. The attribute argv. And notice that it's all highlighted. I can go one by one, but I can do it something like this. Say 1, $, substitute sys to np.sys. So this will just substitute all of them to that. And the only one that I had already changed, I'm going to take that one and p out here, and everything else should be only once. So now notice that when I say if length of np.sys is there, now we, instead of using the sys module, we use the numpy module as np, and then we just use the np.sys.argument here. So this would be same program, but now we are going to say Python NumPy. And if I just do a file on star.sys.py, you can see that both of these one are Python executable files. So I could say, let's just run the NumPy. Since it is executable, let's do this sys star. You can see that it has executable set, and now I don't have to type in Python 3 in front of them, but let me just demonstrate both examples without it and with it there. So NumPy sys.py, and then 10 and 55. So now you can see that number is 65 total. And if I just say the same command, I don't have to say, go ahead, do it as Python. It will just do the same thing, because it knows that a Python interpreter is going to be loaded here. So let's see, head -1 numpy sys.py. And you can see here on the first line, I have this shebang, use a ben env. It's going to find the Python interpreter. So if I say which Python 3, you can see it is user ben Python, or Python Python 3 version, you can see it is 3.8. So whether I run it with Python 3 like this argument here, or run it like this executable, it is going to use this shebang. It's going to just say, okay, look at the binary env and load the interpreter Python 3, and from the second line through the end, it's going to make sure the syntax is correct with Python, and it's going to run it. So this syntax works, and this let's say 100 to 100 to 100, and then 1000 is all of that one is going to work as argument. Let's just come back on the Windows here, and then Jupyter Lab. Yeah, it does look like it is stuck. I'm gonna try one more time here on the console here to see if this one comes back. Let me close this one. I'm going to close this one, completely discard, and then just come back here. And yeah, when this one doesn't show up like this, as soon as you click on it, then it means that it's not responding. That we know for sure. Let's see. Shut down all kernels. And let's see if we could shut down all the kernels and then restore them. New. Okay. Print dir. Yeah, the output is not showing, unfortunately. And I don't have patience to just wait more than a few minutes on this one. Let me just shut it down. I'm gonna go to File, and under the File, you click on the shutdown. Okay, so while this one is shutting down, even the shutdown, you can see it is not responding here. So what you could do is on the operating system side, you can go on the task manager. This is a Windows operating system. On Linux, you can do a pkill on the process or kill -9 on the process. It would be much faster. But because I'm recording, I cannot kill anything that is related to the entire browser, like this one. There's 7 of them. So it would be killing my recording also. I don't want to do that one. Obviously, this command prompt, I can end it and just make sure that whatever it was, it started with Jupyter Notebook, those processes died. So let me just, task manager is fine and everything else is fine. So I leave the rest of them here and then go back to this session and then say the saver, and that's fine, dismiss that one, dismiss this one. I'm going to even close this here and then come back on command prompt here, and then just look at the local host is not going to respond here because the whole thing is down, but if the kernel is still hanging, it might just respond. So you can see it is just not there. That's good. So I'm going to close this one and then start going back to the directory where I want to go. Demo programs, Python, and then I'm going to run Jupyter Lab. So when you do this one, Jupyter Lab, eventually will just open the local host. What I mean by eventually this time, it is a little bit faster because we clear out everything by shutting down and then closing it from the task manager. That is nice. And then right here, this is my command prompt that is opening this Jupyter Lab. And you can see now it is a little bit faster, much faster than before. And then since this one is the name of the program that was hanging, I'm going to close this one. I don't want to just execute that one again. I'm going to start a fresh one. So in order to do this one, let's just go back here on the terminal first and open a terminal to see what we have here. So I have a Windows PowerShell. When you open a terminal and then I'm on that directory, if I say directory store.py, you can see I have a list of Python. Clearing my screen directory, something with sys.py, I have one program, mysys.py, and another one is numpy.sys.py. So if I just look at the mysys.py, that one is basically adding the two numbers, but it's using the import sys argument. So in this case, let's just here, as you can see, we are just getting the number of arguments from that one. So if I just do this, say Python 3 and then mysys.py, and it's going to say not enough argument, clear screen. Okay, that's good. Not enough argument, and let's just give it 55 and 100. So whatever argument you gave, that works with it. And then the number of arguments is displayed as well. And then similarly, if I go here in Python and show you on the Python, I can also go here, Python 3, and then actually do import NumPy as NP, and then say np.sys.argv. Since there's no argument passed in, it is just empty. But if I want to just show insert 55, then I have to do import, let's say, and then I want to just insert this mysys and there. Then I could say np.sys.argv.insert. So insert method is used, but I'm going to insert, and then I say mysys.py here. That would be added there. So now if I just print the argv, it's only that. If I want to just insert again, this time I'm going to insert 55, for example. And then I run the same command, now it's 55 is there. And if I just want to do the same thing with 100, it is 100 is there. So now if I just want to get this one, notice that the last elements that I insert, I can pop. So let's just pop the two last one, which would be the empty one, and then pop the empty first. And then now we're gonna pop the name of the program, which is that one, my sys.py. Now printing the sysargv only have this. This time I'm gonna insert the name of the program, so it will be the first element. You can see the way we were writing the program there. So the name of this program is important. So sys.path is giving you, I'm sorry, np.sys.path will give you the entire path. If you say for item in np.sys.path, and you could just say, show me one at a time, print item, you can get that one also in a nicer format. So np.sys.executable. Was that missing? Yeah, so that one is not there. But on the Linux side, notice that Python 3, sorry, clear the screen, Python 3, import NumPy as np, np.sys.executable. This one is there. Why is that one there and then not on Windows? Let's do this to prove it to you that, yeah, that certain attributes are making sense on one platform versus the other one. So when it is not on another platform, most likely you can get the same thing on a different way, like np.os.system, and you could say which Python 3, that would just say the executable path user bin Python. But let's just say for item and np.sys.sys, I'm going to do a dir of it, dir of np.sys, and then we say f executable. I'm going to just say exact, that's good enough, and item, then print item. And so see how many strings matching the exe, which is executable, exact, and so on. So print item. Notice that here, the executable is there. But the same command, if I run it on a Windows platform, on the Windows, let me just see, on Windows, I have here. So if I run, say, dir of np.sys, you can see the list is big, but because it's harder to see whether executable somewhere here or not, I could write it programmatically, which is for item and dir of np.sys, f exact and item, then give me the list of those ones. So print item. This would just show, notice that executable is here. So why didn't it produce? Maybe I mistyped it. np.sys.execute. Oh yeah, I messed up this step. I was writing an A, executable. That's why it is going to give you. Does not make sense that one would have it and the other one not. And then sys.path, np.sys.path has it too, and there. So let's just check one more thing to see what other programs we can open on NumPy. Here you could just say, go ahead, open a console, and then the console at this time, I could do the import NumPy here, and then run those ones. Let's just do that. Import NumPy as np, and then np.platform. So on the np.platform, on this one, it says 132, and then np.sys.platform. 132, and then on the Windows, that was saying that it is np.sys.platform. This one would say Linux, and on Mac OS X is going to say Darwin BSD. So here we have that one, but at this time I'm going to just delete this one. I don't need it, and I just say go ahead, open a file that I have on the local directory, and just run it from the command line here. So let's say open from path, and I'm going to say numpy sys.py. That file, we have it locally, so it is opening it. And then since I don't need this session, I could go here to make it bigger here. You can see basically the name of the program, numpy.sys. It is all this. And then if I just want to run it, obviously I can run it from command line, or I could run the entire selected cell and then everything there, and then just we already demonstrated this one from the command line actually right here. So let me exit out of here, clear my screen, and directory of NumPy SYS.py. That is the file type NumPy SYS.py. And if I just want to run it, I am going to say Python 3 NumPy SYS.py, and then 200 and 200, 2000, 20,000, whatever, you just add them and you will get the output. So the other thing that you could do is if you go to this program and you just say, well, let's just do a addition, we just do a product of them also. So I could say Control C here and just go to this program. Let's see if this one is a VI or. Actually, let me just demo this one on the Linux side. It's much faster. Clear a screen, and then because on Windows sometimes it hangs and I don't like it like that. So directory, this is much more powerful Linux operating system. So there of NumPy. So vim NumPy SYS.py. Color run color delete color. I just don't like that color like that. Dark blue default. For yeah, that's better. So let's just do that, and then we're gonna say I'm going to do the else part since the argument is there. I'm gonna just do a product. So the product of this one, I'm gonna do multiplication, and then we say this, and then and do another print statement here. Copy this line and then just say the product of those two is equal, and then we just say product. That's good enough. So let's just say cat minus n numpy sys.py. It shows you the line number. Notice that line 12, we added the multiplication line 14 to print it out. So and this time I'm gonna say numpy sys.py, and then I'm gonna give the two arguments, say 10 and 10. Adding those two is 20, multiply it as 100, and then you get the arguments that is there. If I just change this one to a 50, one of them is 60 and the other one is 500, 10 times 5. So you can see this is working. Similarly, if you want to do division, multiplication, addition, modules, power, exponential, everything you do, but you have to be careful when, for example, you're dividing, make sure that you don't divide by 0. There's exception, try an exception handler, resolve it that way, and you're done. Okay. I think I'm going to end the video here. You guys have a great time, and God bless you. And please make sure you make some comments if you need some more improvement for your needs. I will do that. Take care. Bye-bye. I just realized it's Sunday and I have to go to play soccer. So I'm cutting this video a little bit too quick at the end. Take care. Bye-bye.